first of all, welcome to Gower. I'm just going to give you a bit of a cap on what we're doing today and the point of it. Because if after today you don't understand why you have done what I've told you to do or what you've been doing, then you won't be able to answer your exam questions. So everything today is going to be examined in your exam in November. And they will actually let you take in the notes of all the stuff we've done today in with you. So they're not going to be asking you to just regurgitate the stuff you've got in your notes. They're going to be asking you why you did things, what you found out, and trying to get you to evaluate what you've done. So it's really important that you're questioning the process that we're doing today and thinking about why you're actually undertaking it in this way, why you're not doing it a different way, and also evaluating as you go on kind of what went wrong, what worked, how you could improve it as well, because those are the kind of things they're going to be asking you. So we're going to be introducing you to the inquiry process. Do you know anything about the inquiry process? Okay, so there are 6 stages. Okay, well, assume you don't. So 6 stages in the inquiry process, and we're going to start now with doing the first one, which is our planning and our background. Because of course you need to know what you're doing and what the aim of the whole thing is, and to think about an inquiry question. Now for GCSE, we give you the inquiry question, but you're going to use like a checklist to think about, is it an appropriate question, so that if you do go on to do A-level, when you do your NEA, which is your own version of the geography inquiry, you know how to undertake the whole process starting from scratch without the support that we're providing you with today. Now for this actual exam, WJEC gives you a geographical concept and a methodology to follow. So 2 different things, and they say you have to do 2 bits of fieldwork, 1 physical, 1 human, to cover those. When you answer your question, they will ask you specifically about either your inquiry process that covered your methodology or your conceptual framework. So you have to know which one you are talking about. So today we are focusing in on the methodology. And the methodology for this year is transects. So you need to understand the purpose of a transect, what it is, why we're using it today, why it fits with the inquiry question we've got today, and how it provides a really good methodology for undertaking this inquiry. So the first bit, your context and planning, is thinking about a transect. So what is a transect? And in our case, it's really easy to do a transect along a river because our transect is the river. Okay, so as you follow that transect, you're following the river, and if we're looking at differences through that river as we go further downstream, then we're following that river as our transect. So it's definitely not straight, but it's a very obvious line, which is our geographical feature that we're following. Okay, so what we can use it for, there's some examples on your sheet of ideas of how we can use transects. So we can look at things like quality of life or environmental quality as we go through different urban areas. We can look at microclimate as we get away from something or towards something, like up a slope, down a slope, behind a building, in front of a building. We can look at determining patterns of flow across a river. That is a transect, so looking at different things on a very small scale. We can also look at patterns of vegetation growth on a transect, either through a woodland or through a sand dune system, or it could be that we're looking along a beach. So these are all uses for a transect. So I've got 5 examples there. Can you have a quick read through those investigations and tick which ones would be appropriate to use a transect for actually measuring? Yeah, so A, visitor impact decreases with distance from the car park. Is that a transect line? Yeah. Definitely A. Investigation of discharge of a stream taken at various times of the year. Why not?
Because it's over time.
Exactly, and you want to go to the same place to look at distances over time. So that is not a transect investigation. Investigations of plant species diversity with distance away from the beach. Yep, again, distance, going a line away from something. Investigation into plant species, done that one. Investigating people's perception of a place, comparing locals to tourists.
Yeah.
Are those people going to be distributed along a line? Tourist, no, exactly. So no, that's going to be random or opportunistic. And then last of all, the sediment sorting of a beach profile. Yeah, because you can go up the beach, you could go across the beach, but that is a line away or across a geographical feature. Excellent. So when we think about our transect, it's got to be an appropriate landscape and appropriate way of collecting data to answer our inquiry question, but we also need to think about the points along that line. We're not going to be measuring something every millisecond or every moment or every meter of that transect. So we need to think about the frequency of our sampling points. So what's going to determine how frequent we undertake our data collection? So how many? So the last one is, where do we start and finish the transect? So think about our geographical feature, what we're using as a transect. What's the obvious starting point on a transect? The source. Okay, so that is the source. That's obvious. That's the start of our geographical feature. And the end? The mouth. That's the end of our geographical feature. So what is sampling, first of all? Why do... Excellent. So yes, so the location of your data collection. We cannot sample every place. Okay. So what we need to think about now, because we've got our kind of sampling technique, we've got our think about what we're actually covering in terms of methodology. We need to consider a geographical question. Now, as I said, in GCSE, we give you the geographical question and then you just say, is it a suitable one? So if you turn the page over, this is the geographical question we're working on today. Inquiry question. The overarching inquiry question is, how does the discharge of River Ilston change as you move downstream? And because it's such a big question, we need to subdivide it into sub-questions so that we know exactly what we're measuring. So we are measuring the relationship between the river depth and the distance from the source. So we're always going to be moving away from the source. So we can look at depth. We can look at the relationship between the river width and the distance from source. We can look at the river velocity, and we can look at the cross-sectional area. And with that information, we can put it all together to answer that question on discharge. So I'm just going to give you a quick checklist of how to work out if this is a good inquiry question. I want you to answer if it's yes or no. So first of all, checklist. The first one is, it covers a geographical concept. Is there geography in that question? Which is the geography? Words. Discharge and river. That's geography. Tick. Does it have a location? Yeah. What's the location? River Ilston. It's specific to one river. Is it capable to actually answer sub-questions? Can you answer those sub-questions? Yep. Okay. Is it feasible to do it in the time we've got? Do you think we can measure all of those? Okay. Can we actually undertake all parts of the inquiry process? So, for example, can you collect that data? Do you think you could analyse it by calculating means and calculating cross-section areas? Could you turn it into graphs or charts of some kind to present it? Could you undertake a conclusion based on that data to answer those questions? And can you evaluate what you've done to say whether it was a good investigation or not? Brilliant. So that means you can access all 6 parts of the inquiry process. So that means that is a suitable question. Okay. Now, underneath in that box, there is an exam question. That's the kind of thing they would ask you. That's strictly from one of the exams. Okay. So they will not ask you well, you'll have to write your inquiry question, but the question won't be, what's your inquiry question? Write it here. That's too easy. It will be you justifying it and how did you do it? Think about the selection of your sampling points, the selection of the transect. Why did you start your transect there? Why did you finish it there? Why did you do 10 sampling points? Why did you use stratified or systematic sampling? They're asking you why all the time, not necessarily how. So, that's what you need to be able to answer. Okay, so that is the first stage of the inquiry process done. That is our data, our planning and our background. So the next stage we're going on to is our data collection. So we're going to think about how we're going to measure those attributes to be able to answer that inquiry question and those sub-questions. So in order to calculate discharge, which is what our inquiry question is all about, we need to measure those things that we put in our sub-question. So we need to measure the width of our river. We need to measure the depth of the river so that we can calculate a cross-sectional area, and we need to measure the velocity of our river. So those are the 3 attributes that you are going to measure today, and we're going to place you in different locations where there is water to try and do our measuring. Now, we might find we've got major problems at this location, but you can still undertake the data collection and then you can see what the problems are. So we're going to start, if you look on your sheet, it says distance from the bank in centimetres. That's because our whole width of our river needs to be taken into account. And although we're measuring the width of it, we also need to measure at certain points along the width of it. So the first thing you're going to do is you're going to lay out a tape measure from the width of the bank, from one bank to the other bank. One person takes the tape measure across to the bank, and you either put it in with a peg or you hold it and you reel it out to the other side and then onto the other bank. Okay, so the distance from that side of the bank to this side is going to be our river width. So can you see where it says width meters equals? That's where you put that reading in. Okay, you're also going to put that reading at the end of this table. So at the end of this table, can you add an 11? And underneath there, so you say it says 1 to all the 10, just add an 11th column. It's only for the top one. And that is your width of the river. So this width of the river at this point here is going to be, so up to, I'm going to go up to here because I know the river never goes up that high, 2 meters 60. So I put 2 meters 60 just above 11. Okay? So you're going to put an 11 next to 10. So on the edge, so add another column. Yep. There is a reason for this. It means that you can do a graph. You've got both ends, but you've also got 10 readings. It means your maths is easier. So what we're going to do to measure the depth is we're going to divide this width by 10. So if our first reading for depth, it starts at this peg here, okay? On your table it says distance from the bank is 0. So on number 1, on every single ones of your sites, the first letter, the first number in that will be 0. 0 meters or 0 centimeters from the bank. Got that? Yep. Then you take your meter ruler to the peg, put your meter ruler into the water till it hits the ground, take your thumb, measure it where the ruler is, hitting the water, lift it out. And at this point, there is no water. So we write 0. Okay, don't write that down because this might not be your spot. Okay. Now, if the width of the river here is 2 meters 60, where's going to be my next location along this transect, along this line to take my reading? 26 centimeters. Okay, so we're going to go up in those 26s. Okay, so we go to 26 centimeters, take another one, it's 0 again, put 0. Next one, 26 times 2, 52, we go to 52, take another reading, might still be 0. Keep going. Once you've got all those, we can calculate the average depth. This is something you can do back at school, so if we haven't got time to do this, you can do the calculations afterwards. But the average depth, we can then calculate our average depth times our width, and that will give us our cross-sectional area. So we've already covered 3 of those sub-questions. All right, again, if you haven't got time to do the maths, that's something you can work on at home. All we need is those numbers along that line. Right, last thing you're going to measure is the velocity of the water. You are going to measure the velocity over 1 meter. Not ideal. Realistically, we want 5 meters, but I cannot literally see 5 meters of flowing water here. I can't even see 1 meter. So you need a few people to do this. One person holds the meter ruler so you can see where the start and stop points are, and they keep that straight and keep that still. Somebody will then drop a cork at one end, somebody will catch it at the other end, and somebody else will time how long it takes the cork to get from one end to the other. And that will be your measurement of how long it takes the cork to do 1 meter. So how many seconds to do 1 meter. So if I just show you though, you might see what the problem is. Oh, it is actually moving. So there you go, fast forward. There we go. Then they give you your reading in seconds. If we're doing speed, what's the formula for speed? Distance over time. So don't get confused and start going that it's divided by 1. It is distance, that's 1 divided by the time in seconds. So it's meters divided by seconds. All the other things that you're writing down probably might be an idea not to do the calculations yet, because everything has to be in meters. Okay, this is where people get wrong. If you start doing things in centimetres and putting them into the calculation in centimetres, then you're going to be 2 decimal points out. So I would leave the calculations probably till you get back to school, check them, make sure that you're not standing in 2 metres of water when it's actually 0.2 metres of water. But take all your readings. So that, if you can do that multiple times, fine. If it's not flowing at all, fine. Just write down what you saw and then write some notes to explain the problems doing this method. Okay, everyone got that? And that's all you are going to do at each of our sites. So we're going to repeat this over and over again in as many different places that we can get to, closer to the mouth and further away from the source. For the velocity, if you're repeating it, if you do it on the left bank, that's the L, the centre, and the right bank, brilliant. Absolutely impossible to do here. But if later on, especially close to the mouth, if we can go to the left and the right and the centre and repeat it, brilliant. Okay, so if you look at your handout, we have completed, or you have completed, your second stage. So we did the planning at the beginning. The second stage was the data collection. You've done all that for our sites. And now we need to think about how we're going to use that to answer our inquiry question and our sub-questions. So the next stage is our data presentation and our data analysis. Doesn't really matter which order you do those in. It might be worth doing your analysis first, because for lots of your sub-questions, you need to combine data. So think about, we've done how many sites? In fact, at every single location, 5 groups did an individual site. They were very close to each other. So as a class, you've actually done a lot more than just 7 locations. Now, we haven't defined exactly where your location was within a few meters, but you could think about, right, we could actually double that by saying who was the top group, who was the bottom group, and the distance between you was about 50 meters. So we could be more precise in our data. So thinking about presenting that data or analysing it, what do you think we should do to it to make sense of it so we can work out the answers to those sub-questions and that inquiry question? What do we need to do? We've got a lot of data. We need to summarise it. Averages, yep. So especially to calculate your discharge data, you've got all that information. You might have even started calculating it on your sheet. So you need to get your average for your depth readings. You then need to calculate the average for your velocity readings if you manage to do 3 from each location or from some locations. You then need to analyse that by calculating your discharge by multiplying your cross-sectional area by your velocity. So you will get a reading then for each side. So who could tell me what discharge actually is? What is discharge in a river?
Cross-section area multiplied by velocity.
Okay, but what does it actually mean?
Per second.
That's what it's...
Volume of water in a river that passes a point in a certain amount of time.
Excellent, there we go. So we're looking at volume. So making sense of it, you need to make sure you've got the right units. So if you've measured depth in centimetres, and you've measured your speed in meters per second, and you put that together, you will not get the right answer in meters per second cubed, which is what we have of our cubics, is what we measure discharge in. Everything has to be in meters. So part of the analysis would be actually to get your data into the right measurements. So we need it in meters, everything in meters. If you're graphing that, it might be really difficult trying to graph something that is 0.01 meters. So you might graph it in centimeters. So that data in centimeters might still be useful. Can you think about what type of graphs might be appropriate for getting the answers to those questions, those sub-questions?
Line graph.
A line. Why a line?
Because it's two pieces of number and it's continuous.
So we've got continuous data, two numbers, yep. So if we did ours, what's going to be along the bottom? What's on our x-axis? So the distance, that's our data, that's our independent variable, that's what we're measuring, we're changing, we're choosing. And then along the other side, our dependent variable, we could do discharge. Yep, so that would answer our big question. What about the sub-questions? Depth, so again, we could do average depth. You could even put average depth, maybe velocity, maybe width on the same graph with 3 lines of different colours. Yep, you could do that. If we're looking for a relationship, which is what our inquiry question is, what's the relationship between the distance from the source and all of those variables, would a line graph be the best way to see a relationship? We're looking for a...
Without drawing the lines.
Yes, exactly. A line graph without drawing the lines. So a scatter graph will give us the points. Why is a scatter graph better than a line graph for this data that we've got here?
Correlation.
You can identify anomalies.
We can see anomalies, we can see relationship or a pattern. You've also, remember, for each site, we've got 5 different data sets. We can look for clustering. So for example, if you've got one group that's up here and we've added that into our averaging, that's going to skew your data. Whereas if we do a scatter of all of your group's data, we can look for clustering, we can then draw what to give us, oh guys, we're going to have to move. We can get a line of best fit.